Okay, Chapter 8, Section 2 is all about types of reactions. This video is going to be primarily a note-taking video, so make sure you have your notes ready so you can write down notes about the different types of reactions. Before we get started, just give yourself a little pre-test. Up here, 5 different types of reactions. Down here, 5 different reactions. Try and match each with each so you get an idea of what's going on. Okay, hopefully you've made your attempt. Your paper looks like this. First one being a synthesis and a combination reaction. Second one being a decomposition reaction. Third one being a combustion. Fourth one, a couple examples of single displacement. And the fifth one is double displacement. We're going to now go through each one of these reactions and you're going to mark down notes on how to identify each one. The reason why we have these kind of reactions, or why we have different types of reactions, even though they all look the same and follow similar rules, it's important for us to group them so we can better predict what kind of product is going to happen. If we know what kind of reaction is, then we can better predict the product. Starting off with combination and synthesis reaction. This is when 2 or more substances react to make a single product. I should say product there. Okay? So an example, 2 no-name elements, A plus B, yields AB together. Sodium and chloride coming together to yield sodium chloride is one, or the creation of rust doing iron and oxygen making iron oxide, iron 3 oxide. This example here, if you remember from our lab, this is magnesium. And there's oxygen out there. Okay, so if you do magnesium and oxygen, you get magnesium oxide. G plus O. And remember from our balancing, we need to balance this out, so we put a 2 here, a 2 there, and there's a balanced magnesium oxide equation. So remember, combination synthesis, 2 or more into one product. Here's an example that similar but a little bit different to that. It's a combination reaction where it's carbon dioxide and water making glucose and then oxygen. So it's 2 or more into 2 different products, but really the big one is we're making the new product here. If you guys remember biology, you might want to double check on that reaction. That's one that you could remember from last year. Decomposition reactions is when there's a decomposing or breaking down, okay? You break down, so that is a single compound breaking down into 2 or more elements or new compounds. The general form A and B, the compound AB yields A plus B. A couple real life examples here of decomposition where a single compound is breaking down into its parts or into a new compound. Here's a picture of water. Water can actually go through decomposition reaction. However, you also need a little help because obviously, as we see, water is pretty happy by itself. But when you add electricity, remember this symbol over here, put something over the yield symbol, it means it's added in. So if you take water and you run electricity through it, you can break down that water into hydrogen gas and oxygen gas as shown here. That is a decomposition reaction. Combustion reactions. Combustion reactions is when you are combining something with oxygen. And what you get out of that is the release of heat and light. Now something to note here, a lot of people think of combustion reactions, fire reactions, of adding in heat. And really that's not the case. Sometimes you have to add in to get the reaction started, but then the reaction itself, the reaction with oxygen is what creates the heat. So think of a fire giving off heat rather than taking it in. And the reaction that's happening in that fire is actually giving off the heat. Example of combustion right here. Okay, you've got methane gas reacting with oxygen to create carbon, also known as soot, and water. So combustion reactions, you're looking for anything reacting with your oxygen and giving off heat. Single displacement reaction. Single displacement reaction is when the atoms of one element replace the atoms of another element in the compound. Or quickly, if I've got my general terms, A plus BX yields AX plus B, you can see how the A displaced the B and the B got kicked out. In this case, you have a cation displacement. It's also possible to have an anion displacement where you have a X plus B Y, and the anion gets kicked out and you get. So single displacement can happen either with the cation or the anion. Example of a single displacement here. Okay, you've got copper chloride with aluminum. The copper kicks out the aluminum, or excuse me, aluminum kicks out the copper, and so you yield aluminum chloride and copper by itself. Oops. Double displacement, a lot of notes here, so make sure you press pause and get these down. A double displacement, just as it sounds, a double displacement is when there's an ion exchange between two different compounds. So if you look at the general example here, your AX plus BY yields AY plus BX. Okay, so there's the X displacing the Y and the Y displacing the X. Okay, so it's a double displacement where the ions are changed between two different compounds. One more time, make sure you press pause and get all this down and look it over. Double displacement, here's an example of this with also a little precipitate showing you that there's a reaction happening. Okay, you've got lead nitrate and potassium chromate being mixed together, two liquids, and then you get lead chromate, and that's your precipitate here, and potassium nitrate staying in its liquid form. So as you can see down here, to make the color coding here, A is the lead, which is first with the nitrate and then comes over and displaces the potassium to bond with the chromate. Okay? After watching this video a couple times, making sure you get down your notes before next class, I want you guys to look here, page 284 of your text. Try 2, 3, A, B, C, and D, and then 4, A, B, C, and D. If you get those and you feel pretty good, feel free to look at 5, but it's not required. It's kind of a higher level, taking these skills and applying them to a situation. Thank you.